Today's lesson is on measuring lines related to circles, and it's in 4 parts. The first part is a review of lines and circles and how they interact with each other. One of the ways they interact is through something called chords, which we'll learn about, and how do we measure intersecting chords. Another way they interact is a line segment called a secant, and how do you measure intersecting secants. A third way they can interact is tangents. And so how do you measure an intersecting secant with a tangent? And we'll find out that actually that's simply a special case of intersecting secants, and we'll use the same formula. So first let's talk about lines and circles. And there are 3 types of line segments that can interact with a circle. The first is called a tangent, and that's a line that touches a circle at one point. And there's an example of one right there. Second type is called a secant, and that cuts the circle at 2 points. And there's an example of a secant cutting a circle at 2 different points. Finally, you have something called a chord, which has its endpoints on a circle, and there's an example of a chord. Notice that any secant has a chord included inside of it. Now we're going to talk about how to measure intersecting chords. So the product of the lengths of the parts of a chord is equal to the product of the lengths of the part of the chord that intersected with it. That is not particularly clear, but let's try it. If we do a drawing, it should become much more so. So here's a circle, and I'm going to put 2 different chords in it. And I'm going to color those chords. This one's blue and this one's red to make it easy to understand. Then what I can do is I'm going to cut the parts of the chords as even different colors. Make this one a bright blue and this one a dotted blue line. This one a bright red and this one a dotted red line. Now we can go back through that original statement and hopefully it should make some sense. The product of the lengths of the part of a chord, so the blue chord, the product of the lengths of those is equal to the product of the lengths of the chord that intersected with it. So once again, that bright blue part and the dotted blue part, the product of those, if you multiply them together, is equal to the bright red part times the dotted red part. And again, let's do an example to see what that means. So if I said the bright blue part is 3, and the dotted blue part is 8, and the red part is 4, what is the value of the dotted red part? Well, if I take all of these values and plug them into my equation, I see that 3 times 8 equals 4 times x. Multiply that out, and I see 24 equals 4x. Divide both sides by 4, and I come up with my answer of x equals 6. So that missing chord, or the missing part of the chord, is 6. Now, let's talk about measuring intersecting secants. When 2 secants have a common endpoint, the product of one external part of a secant times the whole secant is equal to the external part of the other secant times the whole other secant. That is a mouthful to remember. So what I try to remember is outside times the whole equals outside times the whole. Once again, outside times the whole equals outside times the whole. What does that mean? If I have a secant with, if I have 2 secants with a common endpoint, then the product of one of those, I'll make that blue, make this one blue, and this one red, and again we'll make this bright blue and this dotted blue, this dark red and this dotted red. Now the product of one part of the secant times the whole secant, so the whole secant is that blue part plus the light blue part, that's equal to the external part of the other secant, so that would be the bright red part, times the whole secant. So again, that would be red plus the dotted red. Let's see an example of how this works. So imagine that the outside part of the blue secant is 7, and the inside part, or the chord, the blue chord, is 11. The red part is 6, and I'm being asked to find the red chord, the part of the secant inside the circle. So if I plug in my values, I see that 7 times 7 plus 11 equals 6 times 6 plus x. Multiply that out, multiply again, divide by subtract by 36 on both sides, and I end up with 90 equals 6x. Divide both sides by 6, and I see that my missing value of my chord is 15. So x equals 15. The final thing we're going to go over in this lesson is measuring intersecting secants and tangents. And I've started this slide with an example of two secants that we just did. But what if we move one of those secants to become a tangent, like that? Well, what we see is that that light blue part goes away. But the formula still holds. Let's do an example and see what that means. So imagine the bright blue part is 15, so my tangent is 15, and the outside part of my secant is 9, and I'm asked to find the chord inside the circle. We'll call that x. So if I plug in my values, I see that 15 times 15 equals 9 times the value of the whole secant, 9 plus x. Outside times the whole equals outside times the whole. Multiply that out, subtract 81 from both sides, and I get 144 equals 9x. Divide both sides by 9, and I come up with a final value of x equals 16. So the value of that chord is 16.